The most important thing that happened at Starbase was not a launch. It was a rocket being held down while it tried to become one. Booster 19 completed its static fire for Starship Flight 12, and from a distance, it looked almost simple. A tower, a vehicle, a blast of flame, a few seconds of controlled violence on the Texas coast. But that is the illusion. A static fire is not a celebration. It is an interrogation. The vehicle is fueled like it means to leave Earth. The engines are awakened. The pad is attacked by sound, heat pressure, vibration, and flying debris, and nothing is allowed to move. That is the strange part. The machine is built to rise, but the test only succeeds if it stays trapped. At Starbase, this matters because Starship is not just another rocket. It is a system trying to become routine, while still behaving like a natural disaster in metal form. Every launch mount, clamp, pipe valve, tank trench, and deluge line has to survive the moment when the booster turns stored propellant into force. And this is where the story becomes less romantic. Most people see Starship and think about Mars, refueling orbit the moon cities beyond Earth. But before any of that, there is a harsher question sitting beneath the vehicle. Can the ground survive the rocket? Because if the answer is no, then the future does not fail in space. It fails on the pad. Booster 19's static fire is one more step toward Flight 12. But it is also a warning. The rocket is not the only thing being tested anymore. The entire idea of rapid reusable spaceflight is being forced to prove that it can endure its own power. The easy version of the story says SpaceX is testing a booster. That is true, but it is not enough. A booster is only the visible part of the problem. The harder machine is the one built around it. The launch tower, the clamps, the quick disconnects, the methane and oxygen systems, the high-pressure gas, the water deluge, the concrete steel sensors, software roads, crews, closures, weather, and timing. Starship does not launch from a pad. It launches from an ecosystem. And ecosystems fail in quiet ways before they fail loudly. A pipe vibrates harder than expected. A panel tears loose. A valve opens slightly too late. Water arrives at the wrong pressure. A structure survives once, but not 10 times. A system works during a test, then behaves differently when 33 engines ignite beneath a fully loaded vehicle. This is what people often miss about rockets. The launch is not a single event. It is the final visible frame of thousands of smaller decisions that had to hold together. By the time flame appears, most of the danger has already been invited in. That is why static fire tests matter. They are not just checking whether engines can burn. SpaceX already knows Raptor engines can burn. The question is whether they can burn together while trapped in a structure that must absorb the punishment and still be ready for the next flight. Reusability makes this much harder. An expendable rocket only has to leave the ground once. Starship is being asked to make violence repeatable, to turn something that feels like an explosion into an operation. And that is a much colder ambition than simply reaching space. The first wall is not thrust. It is damage. When 33 engines fire beneath a super-heavy booster, the pad is hit by something that behaves less like exhaust and more like an industrial weapon. The flame is obvious. The sound is worse. Pressure waves move through steel concrete plumbing cameras and the ground itself. You can see the violence in small details. Water erupts from the deluge system before ignition because the pad has to be flooded with protection. Not for drama, not for spectacle. The water is there to absorb acoustic energy, reduce heating, and keep reflected force from tearing the launch site apart from below. Without that system, the rocket does not just lift off. It attacks its own birthplace. That is why the repeated deluge tests around Pad 2 are not background activity. They are part of the flight. They are the unseen rehearsal for the moment when the booster's engines turn the launch mount into the most hostile place on Earth for a few seconds. And even then, survival is not guaranteed. A static fire can send debris outward. It can expose weak attachments. It can reveal where panels, covers, ducts, and sensors were not ready for the real environment. A piece of hardware that looks irrelevant from a distance can become a projectile when pressure finds it. This is the brutal honesty of Starbase. Nothing is proven because it looks finished. It is proven when the engines light, the water moves, the clamps hold, the structure shakes, and afterward crews can walk back in and find a pad that is damaged, less than expected. Flight 12 does not begin when Starship rises. It begins here with the ground trying not to break. The deeper system is time, not the countdown clock. Not the schedule people watch from a live stream. The real clock is buried inside the hardware. Every static fire spins the machine a little. Metal expands, seals heat, bearings load, welds flex, sensors drift. Ground equipment absorbs shock. The booster may remain standing, but nothing returns perfectly untouched. That is the hidden cost of making spaceflight look routine. A reusable rocket is not simply a rocket that comes back. It is a rocket that comes back with enough of its certainty intact. Enough margin, enough predictability, enough confidence that the next flight is not gambling on damage you failed to see. And this is where Starship becomes more than a vehicle. It becomes a maintenance problem at planetary scale. The booster, the ship, the tower, the tank farm, the transporters, the test stands, the factories, the roads, the cranes, the weather windows, the flight license, the sea lanes, the airspace, the workforce. All of it has to move in rhythm. If one piece falls behind, the system slows down. Spaceflight has always been expensive because Earth is hard to leave. Starship is trying to attack that cost with repetition. Build faster, test faster, fly faster. Learn from damage before it becomes catastrophe. Except that some parts of the path will be ugly, because the alternative is pretending the unknown is smaller than it is. But the unknown does not shrink because a rocket is stainless steel. It shrinks because the same brutal event is performed again and again until the system stops being surprised. Booster 19's static fire is one of those moments. A few seconds of ignition, weeks of preparation behind it. And beneath all of it, a deeper question. Can a rocket this powerful ever become ordinary, without first teaching everything around it how to survive? If Starship works, it does not just change one company's launch cadence. It changes the assumed speed of the future. That is why these tests feel larger than the footage suggests. A booster static fire at Starbase is not only about Flight 12. It is about whether heavy space infrastructure can move from rare national event to industrial process. That shift sounds inspiring until you look closely. Because industrializing space does not remove danger. It distributes it. The risk moves into procedures, maintenance cycles, launchpad wear, regulatory decisions, supply chains, and human judgment. The catastrophe becomes less obvious, but not less possible. This is the price of ambition at scale. To build a civilization that can place massive payloads in orbit, assemble stations, refuel spacecraft, send hardware to the moon, or even attempt Mars, humanity has to make peace with a machine that burns thousands of tons of propellant and asks to be used again, not once, again and again. The static fire is a small version of that bargain. The booster proves it can wake up. The pad proves it can take the impact. The teams prove they can prepare, observe, repair, and continue. But every success also raises the standard. Now it must happen cleaner, then faster, then with a ship on top, then with recovery, then with reuse, then with payloads that matter. And eventually, if the system matures, the violence will become almost invisible to the people depending on it. That may be the strangest outcome of all. A thing that once shook the coast and shattered assumptions becomes infrastructure. But infrastructure is never magic. It is trust built on inspected damage. Booster 19's static fire ended in seconds. But seconds are misleading in rocketry. A few seconds can decide whether months of work were real, whether the pad can endure another strike, whether the next flight moves closer, or whether the system must pause and listen to what broke. That is the quiet truth behind Starship Flight 12. Progress does not always look like a rocket crossing the sky. Sometimes it looks like clamps holding, water erupting, engines firing into restraint, steel surviving long enough to be trusted again. And somewhere inside, that noise is the future SpaceX is trying to force into existence. Not the clean future in renderings. Not the silent one where ships drift elegantly between worlds. The real future begins in mud, salt air, heat repairs, inspections, and the dull patience of engineering. It begins with the understanding that space is not waiting for us. Earth is holding us down with gravity, cost, weather, regulation, fragility, and consequence. Every vehicle that leaves has to defeat all of that first. Not symbolically, physically. Booster 19 did not go anywhere. That was the point. It stood still while its engines tried to turn the pad into a wound. And when the fire stopped, the real test began: what survived, what changed, what must be rebuilt before the next attempt. This is how the frontier actually moves. Not with certainty, not with applause, but with machines powerful enough to frighten their makers, being tested until fear becomes data. And one day, if this works, people may watch a Starship rise and think it looks normal. They will not see the ground that had to learn how to endure it.